Hi, Mr. Bucko here, again with problem number 10 from your Algebra Chapter 1 practice test. So I have 10A and 10B, it's a two-part question on the screen. We have 10A says that a pattern of dots is shown below, and we want to draw the fourth term in the sequence for the design below. So the first term is one dot, the second term has two dots, and then there's a dot below. The third term has three dots, and then two dots below. So if I was going to draw the fourth term, I think the fourth term would look something like this, where there are four dots on top and then three below, as it pertains to the pattern we're seeing. So the top row has the number of dots as the term, and then the bottom row has one less dot. Look at it that way, or many other ways as well. So this is what that fourth term will look like. And then what I'm going to do is just kind of make a note as to how many dots are in each of these terms, because that's what's going to help us with question 10B here. So I notice that there is one dot in the first term, there are three dots in the second, there are five in the third, and then there are seven in the fourth. So when I ask the question, when I'm asked the question, or asked to find the number of dots in the nth term, it's crucial that we know how many dots there are. So using the pattern of dots from question 10A, we want to write an expression for the number of dots in the nth term. So what this means is that we just want a rule. What if I wanted to find out how many dots were in the 90th term? And I could probably figure that out because I can hopefully identify a pattern here, but that's going to take a long time. If I want to find out how many dots are in the 57th term, that's going to take a long time. I could do it, but it's going to take a long time if I'm just going to follow this pattern, which this pattern is, if we notice, that we're just adding two dots every time. So the fifth term will have 9 dots, and the sixth term will have 11, so on and so forth. Well, what about the 95th term? I'm not going to add 2 all those many times just to get to 95. It's not going to happen. I could do it, but it's not reasonable to do because it's just going to take so long. So we want to find a quicker way to do it. So the fact that we identified, or that we can identify that this is changing by 2 here, that's crucial. It's our change from one to the other. So if I'm going to find how many dots are in the 93rd term, I would just add 2 together 93 times, but there's a shorter way to do that. There's a shorter way to add 2 93 times, and that's by multiplication. So if I'm looking for the 93rd term, or the 17th term, or the 140th term, I'm going to just multiply 2 by whatever that term I'm looking for. So what if it's the nth term? So any term. Well, I'm just going to do 2 times n. So I don't have to add 2 together a whole bunch of times. I can just do 2 times n. So let's try this and see what happens with the third term. You see what happens. I mean, I can add 3 together, or 2 together 3 times pretty quick. But let's do 2 times 3. 2 times 3 is 6. But there are 5 dots in the third term. So that really didn't work. It's one more. Let's try the fourth. 4 times 2 is 8, but there are 7 dots. Also one more than we need. Try the second term. 2 times 2 is 4, but there are actually 3, which is one more than we need. 2 times 1, right here, is 2, but there's only 1 dot. So we'll notice that when we multiply each of these term numbers by 2, we end up with one more dot than we need. So then our rule is going to be, well, let's just subtract 1, and that will give us how many dots are in that term. So now it will work. 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. This is our rule. And where these numbers come from is not a coincidence. The 2 right here comes from, that's the pattern. That's the change that we're seeing from one term to the next. Plus 2, plus 2, plus 2. The fact that we're multiplying by a positive 2 is not a coincidence. It's where that comes from. The minus 1 is a little bit trickier to find out where that comes from, a little bit more complicated to understand where that comes from, but that's kind of compensating for when we do that multiplication of 3 times 2, we don't get what we're looking for, so we have to subtract 1. When we do 2 times 4, we don't get what we're looking for, so we have to subtract 1. Another way to look at where this negative 1 comes from is, what if we were to go backwards and find the 0th term, which isn't even a real thing? What does the 0th term look like? What if this pattern was continuing? Let's forget that these dots even exist. What if we were looking at the 0th term? What number would need to go here to maintain this pattern? Well, it's increasing by 2 going to the right. So going from the left, it'll be subtracting 2. So this number right here would be a -1. And the fact that the 0th term is a -1 and that we have to subtract 1 here is not a coincidence. So where these numbers come from can be seen in the pattern, and it's crucial to identify those two pieces to come up with the rule. It's not just a matter of guessing numbers. You can see where these numbers come from by looking at the pattern itself. So the rule for the nth term would be 2 times n minus 1.